Yeah, so let's start with our last time chapter, namely divisibility. So we are working in number theory, and essentially our set is either set of natural numbers, which is denoted by n, or set of integers, which is denoted by z. So what is set of natural numbers? They are numbers 1, 2, 3, 4, 5, 6, and so on, no end. So we say they are infinite many. And set of integers is 0, all natural numbers, that is 1, 2, 3, 4, and so on, and their additive inverses -1, -2, -3, and so on. Again, infinite many integers. Right? So we have defined divisibility. Just a minute. Yeah. So we have defined last time divisibility. So suppose, so our definition was following definition. So suppose D is non-zero number and n is any integer. So we say number D divides number n, and what are our notation? D vertical line n. What it means? Number this side divides number this side. That's it. It does not mean D by n or n by D. Fine. So we say D divides n if, can somebody tell the definition? You can raise your hand. Ashriya, yes.
So if n by d is an integer,
Little better.
if d can be expressed as n multiplied by k, where k is an integer.
It's other way around. So D divides n if n I can write as D times some integer. So say D times Q for some Q, for some integer Q. So I'll say Q belongs to Z, which means Q is integer. All of you agree with the definition? Akia, yes.
Sir, I wanted to say the definition.
Oh, okay, yes.
Okay.
So for example, we say 3 divides 12. Why? Because we can express 12 as 3 into some integer, 3 into 4. But we say 5 does not divide 12. Why? Because 12 cannot be expressed as 5 into some integer. Right? In fact, 12 is 5 into 2.4, and 2.4 is not an integer. All of you agree?
Yes, sir.
Yeah. So that's our definition. And we'll go ahead with problems now. So last time we have seen many properties of divisibility, and the useful one or most important one is following. If D divides number A, D divides number B, then D divides any combination of A and B, like A plus B, A minus B, 2A plus 3B, or more generally. So I'll say D divides A, D divides B implies D divides any integer m times A plus any integer n times B, for any mn in Z belonging to Z. Okay, so just to have a quick revision, whether you understood the concept, let's do some true or false type problems. I'll go to next page. So state true or false, and if it is true, we have to prove it, we have to justify it. If it is false, we have to give one counter example. So one example which disobeys the fact. Okay. So if you want to claim false, just one counter example is sufficient. What I mean by counter example, kind of anti example, right? One counter example is enough. So one example which does not satisfy the given property or given condition. Okay, and if it is true, we have to justify it. So justify logically. We have to prove it logically. I write a statement and in chat, I just said that.
So, sir, it's very easy in general to disprove a statement, but very hard to prove it.
Oh yeah, good. Yeah. So when it's true, in fact, essentially we are proving each and every case, right? But if you want to disprove, just you have to give one instance where it's not. That you can take your hand down. Yeah. Okay. So I'll write the statement, and in chat box you can write down answer only to me, whether it's true or false. Don't disclose the answer. Don't write it to everyone. And be ready with some counter example or some kind of proof if it's true. Yeah, so whatever I write, A, B, C, etc., they're all natural numbers. So there is no question of zero. So let's assume that A, B, C, D are natural numbers. But more generally, whatever results I'm doing here or I'm writing here, they will be true even for integers. Only thing, our divisor will be non-zero in every case. Fine? Yeah, so first one, if A divides product B into C, if A divides product B into C, then A divides B or A divides C. It divides one of them. Pranav, you have written both. So if a number A divides the product of two numbers B and C, then number A divides either B or it divides C. That's the question. Or I mean, that's the statement. You have to say whether it's true or false. If it is true, try to prove it with some arguments. If it is false, be ready with one counter example. So one example which does not satisfy this.
Sir, I gave you an example. Did you see that?
Yes, Toyota. Yes, yes, can, yeah. Okay, some people say it's true, some people say it's false.
Sir,
Yes, Siddharth.
it's true.
So if it is true, you have to give some.
Oh yeah, sorry, sir. I thought you were saying it's false, sir. It's false. There is a very easy counter example. 6 divides 24, which is 3 into 8.
Okay.
6 does not divide 3 and 6 does not divide 8.
Okay. Yeah. So we can give many counter examples, right?
So that means this is evidently false.
Yeah. So some people have said true, but it's false actually. Let me give some counter example. So for example, 4 divides 2 into 6, that is 12. Okay, so this is like my A, this is like my B and C. So A divides BC, right? But 4 does not divide 2, nor 4 divides 6. So what are the statement? If A divides BC, then either A divides B or A divides C. Yes, Kian?
Sir, this statement that if A divides B, C, then A divides B or C is true, or if and only if A is a prime number.
Very good, yeah.
I can prove that by saying that suppose if A is not a prime number, then it can be factorized into suppose A1 and A2.
Right?
Then that will divide B, the product of B and C.
Yes.
So B is either, so we can have B is equal to A1 into Q1 and C is equal to A2 into Q2. So
Right.
so A does not divide either B or C, but it does divide the product of B and C.
Yeah.
But if A is a prime number, then it can only have one and another number. So it does not work in that case.
Yes.
It
Yes,
has
very
to.
good. So what Kian says is if A is prime, and A divides product, A divides one of them. And A is prime, then A divides one of them, either B or C. But if it is not, this fact will prove later, not right now, since we haven't done properties of primes so far. And if at all something is not prime, so for example, 6 is not prime. Okay, so 6 is 2 into 3. And I can surely say 6 divides 2 into 3. Every number divides itself, right? But 6 does not divide 2, nor 6 divides 3, because in fact, the factors are smaller than the number, right? So everyone is clear with this one? Those who have written answer as true? Yes, Kushal?
Sir, it can be true if B and C are one, right?
If B and C are?
One.
Both are one or one of them?
Both of them are one.
If B and C are both 1, then A must be 1, because only divisor of 1 is 1. Right?
Right.
Yeah. So anybody has any doubt? Animal?
Sir, when we are using a counter example, we can just substitute it with values until it is not true, or whether it is equal or whether it is not equal, right? Why do we go with like complex, like prime?
No, that was some extra comment. So that was some extra comment. So anyways, if you give some example like this, that would be enough. Something like this or something like this. That would be enough. Okay?
Okay, sir.
Adri,
Sir, the statement would be true if A, B, C are both the same or same numbers, right?
so what do you mean?
So, like, if we take A, B, and C as the same natural numbers, the statement can be true.
Yeah, but that won't be if and only. I mean, one way. It's one way too. If all A, B, C are same equal, then obviously A divides B or A divides C. One over. In fact, it divides both of them. In that case.
Yes.
Yeah. Especially those who have said in answer in chat box, the statement is true. Is it clear to you now? It's not true. It's false, and there are many counter examples. Now, even you can try to find your own counter example later on. Fine. Yes, Kian.
Sir, I don't think A doesn't have to be prime to always divide for the statement to be true. I think so suppose like how
Kian will come to that later because we haven't done primes and their properties.
no
So
not I'm not talking about primes, sir. I was talking about like 6. Suppose A, B, and C are the same number, so then 6 and 6 and 6. So 6 will divide.
yeah, in
So
that case, it will divide both B as well as C, right? Because they're same basically.
but it will divide at least one of them. Will divide at least one.
No,
So
why at least one? They are all same, so it will divide both of them.
it will divide both, but 36 can be factored into other ways, and so 3 into 12 or 24. I mean, 36 into 1. No, sorry, sir.
Yeah. So everybody's doubts are clear. Shall we go ahead? Okay, somewhat similar question. You have to say true or false in chat box. Yeah. A, if A divides B plus C, then A divides B or A divides C, one of them. Don't disclose the answer. You can write in chat box only to me. Yes, Shreya, Anju, correct. Vivan, correct. Siddharth, correct. Siddharth, if you are writing false, you can give some counter example also there. Yes, Achutan.
Is this okay?
Sir, I have also sent the solution.
Yeah.
Sir, is my solution correct?
Yes, yes.
Counter example.
Yes, yes. Yes, Arya, correct. Jinal, correct. Ashik, correct. Okay, so this time there is no true answer. All answers are false. Okay, so let's start the discussion. So unanimously everyone says it's false now. And again, you can produce many examples. So for example, I have to give one example. For example, say 4 I'll break as 2 plus 2, right? So 4 divides itself 2 plus 2. But 4 does not divide 2, or other one is also 2. Okay, or if you want, instead of 2 and 2, take two different numbers. So 4 divides say 3 plus 1, but 4 does not divide 3, nor 4 divides 1. I hope we should not spend much time on this because everyone has said false unanimously. Shall we go ahead?
Yes, sir.
Sir.
Okay, now stop writing answers in chat box. We'll go to next question. Third one, if A divides B, then A square divides B square. Shreya, you are the first one to give the answer. So you have to give whatever argument. Fine?
Okay, sir.
Wait.
So,
Let others put the answer. We'll do after. Okay. Nimal, do you have doubt?
Yes, sir.
Yeah. What's that?
So we have to tell whether the both are equal or both are not equal. So we have to tell whether it is equal or not equal. Is that what the question's meaning?
No, they are not equal. If number A divides number B, so B is multiple of A, may not be equal. So some 2 times A, 3 times A, whatever. Then we have to, the statement says, then A square also divides B square. So question is whether this is true or false. So if it's true, you have to give some argument. If it is false, you have to give one example.
So what? I can't understand the statement, sir.
See, if number A divides number B, then number A square divides number B square. I'm not saying it's true or false. So you think about it, whether it's true or false. If it is true, you have to prove it. If it is false, give one example where A divides B, but A square does not divide B square. Is
Okay.
it okay?
Sir. Sir. Sir.
Yes.
So you're asking whether both the statements are like equal value or not?
So what do you think? It's true or false? That you have to write in chat box. And if you are saying answer is true, then you have to prove it. If you are saying answer is false, you have to give one example.
Okay, sir.
Okay, one
I said
caution.
my answer.
Yes. One word of caution. If you are saying true, don't produce example. For true, just one example is not enough. If your answer is true, one example is not enough. You have to prove in general in terms of ABCD, etc. Right? Shreya, now you can answer it. So people have answered now.
Okay, so A divides B, which means that B is equal to AQ, where
Just a
Q is an
minute. Just a
integer.
minute. Let me write. So yes, so given A divides B, and which means B I can write as A times some integer. Yeah.
So squaring both sides, we will get B square is equal to A square into Q square.
Yeah. So B square is AQ square. And shall I write AQ square as A square Q square? Now to be very precise, AQ square is AQ into AQ. But multiplication is commutative, so I can change the order of numbers. So I can take A this side and it will be A square, and Q this side, so it will be Q square. So it's A square times Q square. Everyone agrees? So A square times some integer. Now if Q is integer, Q square is also integer. So A square times some integer is B square, and which means A square divides B square.
Yes.
So once again, some of you have given one example for even if your answer was true. So be clear with this. One example is not enough if you are claiming answer is true. Okay. Shall we go ahead?
Yes, sir.
Yes, sir.
Yes.
Yes, Kushal.
Sir, how is it not false, sir? Because
If it is false, you give me one example where A
Sir,
divides B, but
look,
A square does not divide B square.
10 divided by 5 equals 2, but then 100 divided by 25 equals 4.
10.
And then 2 does not equal 4.
Say it once again. 10.
10 divided by 5 equals 2. 100 divided by 25 equals 4.
See, what you have to say is something like 5 divides 10. Don't say 10 by 5. See, we are saying that this symbol just indicates that number this side divides number this side. So we want to say that if number A divides number B, then number A square also divides number B square. And Shreya has given the proof for that. So do you see there is some logical mistake in her argument?
But then even with the mistake, even if you like reverse it, still like
So with your example, what is the so if 5 divides 10, will 5 square divide 10 square?
it won't be equal, sir.
That is fine. They won't be equal. Quotient may not be same. Quotient will be obviously different. But will 5 square divide 10 square?
Yes, sir.
Right? So if you can produce some example where A divides B, but A square does not divide B square, then the statement will be false. Is that okay?
Okay, sir.
Yeah. So are you clear with this argument?
Yes, sir.
Yeah. Yes, and you?
Sir, I just wanted to confirm can the variables take any integer values or is it only for natural numbers?
Right now we are doing with natural numbers, but more generally they could be integers, provided you have to assume that divisor is always non-zero.
Okay, sir. Thank you.
In fact, most of these results were done initially for natural numbers because essentially this was done 2000 years back uh, by Euclid mainly. And in those days, people were not comfortable with, or in fact, they were not knowing negative numbers. So negative numbers were introduced around 5th, 6th century by Indians like Aryabhatta, Brahmagupta, and so on. And in fact, people were comfortable using negative numbers almost in 18th, 19th century. Shreya?
So why do we need the condition that the divisor is not equal to 0?
Yeah, so that was our definition, because see, see, if I multiply by 0, or let me repeat the definition. So we said number d divides number n. If n I can write as d times some integers. Okay. And
Yes.
suppose possible d is 0. Suppose. Then what will happen with n? So
And
0 into anything will be one can prove that is always 0. So n essentially has to be 0.
yes.
Okay.
So yes, but this would work even if even if A and B are both 0.
Yeah, so you mean if it's 0, both are 0, then so you have to claim that 0 divides 0.
Yes. And according to this definition, it works. But if we say that 0 upon 0 is not a
See,
is not an integer. So.
if both are 0, trouble is I can take q as anything 1, 2, 3, 4. So there won't be unique answer. Answers will be different. We want some unique answer for the division.
Okay. Thank you.
So just to avoid all such logical troubles, we assume that divisor is non-zero. Okay. Yeah. So shall we go ahead now?
Yes, sir.
Good. Fourth one. Again, true or false. If square of some number, if a square divides b cube, then a divides b. So now I hope everybody is clear. If you feel it's true, you have to give some proof like this, the way Shreya argued here on downside. So you have to give some logical justification like this in terms of A, B, etc., not for particular example. And if it is false, then you have to give one example which does not satisfy the property. I mean, one example where a square divides b cube, but a does not divide b. Those who are writing false, try to produce one counter example. And those who are writing true, you have to give some logical argument. There are both types of answer, true as well as false, in the chat box. Nimal, it's with condition. I'm not saying always A divides B. If so, question is if A square divides B cube, then whether A divides B or not. That's the question. So you can't just replace AB by any numbers, suitable numbers. See, essentially A square should divide B cube. You have to put such numbers, right?
Sir, so when we substitute any number, it's just we can divide it, right? We would get any quotient. So what do you mean by it cannot divide?
No, I'm not saying it cannot divide. So that's the question. Will it divide? Will A divide B or not? So if it's true, it's fine. If it's false, you have to give some example. But you can't put any number. See, you have to put values of A and B such that A square divides B cube. This is the condition given. Whenever A square divides B cube, question is whether A divides B or not. That is the question.
So when we divide A square and B cube, the answer should be a normal number.
Indeed, yeah.
Oh, okay. Okay, it should not be a decimal, so.
Yeah, so B cube by A square should be some integer.
Okay, sir.
Then whether B by A is again integer, that's the question. Yes, so some of you feel this is true, some of you feel this is false. And I'll go on this side because those who have said false, they have also produced some counter example. So for example, 8 square is 64, right? Divides 4 cube. 4 cube is again 64. 64 divides itself, right? But 8 does not divide 4. So whenever A square divides B cube, that does not mean A divides B always. So here is one example. 8 square divides 4 cube, but it does not divide 4. So the answer is false. It's not true. Correct? And you see that?
Yes, sir. If A is less than B, will the statement be true?
A is less than B. Why is that so?
Sir, if we exchange the places of 4 and 8, like sorry.
So maybe let's say 9 square divides is bigger. Sorry. Yeah. So 9 square divides 24 cube. Is it true?
No, sir. Sir, I think we should have a multiple of 9 only.
Yeah. It's prime square. Can anybody produce quick example? So A is less than B. A square divides B cube, but A does not divide B. Can anybody produce some quick example for this?
Sir, Sir, if 8 is a cube, then sir, if A is a cube, then it is then then only it is possible. And like 27 square is divides 27 square divides 9 cube, and 64 square divides.
But 27 will be bigger than 9. So what
Okay.
she wants is, what
So
she
we
wants
can,
to less
instead of 9, we can take any multiple of 9.
So we want A less than B. That's the point.
Sir, we can take A equals 8 and B equals 12.
Oh, good. Yeah. So 8 square divides 12 cube, right? I get 4, 4, 4. Yeah. Okay. 8
Yeah.
square divides 12 cube. Just check, all of you. 8 square divides 12 cube. Yeah.
Yeah, sir, we can come up with other examples like 27 square, like a 27 square and 27 square and 9 square we have, but 27 is greater than 9. So instead we can have 27 and 36, where
Yeah. Yes.
it will divide.
Yes. Now, Srividya, what do you want to say?
Sir, does it necessarily do both of them necessarily have to be positive? Because can we have -8 also as an option?
Yes. But right now I'm sticking to natural numbers. So because initially, before we started all these problems, I said let ABCD be all natural numbers. Because every time I need not say A not 0, A not 0. Once I say they are naturals, and in fact, in many cases, just by changing the sign, you can convert the result to integers. So right now, I assume that all these are natural numbers, but fine, it's true also for even integers, where our assumption is divisor is non-zero. Yeah, so who asked the question? Yeah, question was nice. So even if A is less than B and A square divides B cube, that does not mean A divide B. So here is nice example. Animal, yes.
Sir, but when we substitute A as 9 and B as 3, we would get the integer 3 as the answer. So the statement would be true that time, right?
No. 9 square divides 3 cube, but see, 9 square does not divide 3 cube.
9 square is 81 and 3 cube is 27. So if it is,
So 81 does not divide 27.
oh yeah, sorry sir, I got confused with cancelling.
Okay. Anybody has any comment or doubt about this problem?
No.
Can we go ahead then?
Yes, sir.
Yes, sir.
Yes. Okay, if A divides B and C divides D, so we have both conditions. Number A divides number B, number C divides number D. Then addition A plus C divides addition B plus D. As usual. You can keep answering in chat box only to me. If you are writing true, be ready with some logical argument. If you are writing false, there itself you can produce one counter example.
Sir, I sent a solution to you.
Okay, I'll check. Yes, yeah, that's fine.
Okay, sir.
Yeah, so again, few people are saying true and majority are saying false. And those who are saying false, they are giving some example. The best way is in fact take A and C as 1 and 1. So 1 divides 2, 1 divides 3. But 1 plus 1, 2 does not divide 2 plus 3, 5. So I'm taking one even number, one odd number so that the sum is odd. And here the sum on left hand side is 2. So 2 cannot divide odd number. Okay, and of course you can produce many such examples. Kushal, have you raised hand?
Sir, A can't equal C or else they have to be the same variable, right, sir?
You can take different values, no problem. So
Sir, because if A is 1, then C can't be 1. Then if A is 1 and C is 1, then C would equal 1. I mean A.
so C in that case will be A. So question is in that case whether A plus A, 2A divides B plus C. So, see, when you say something like this, if there is no condition given, uh, there is no harm taking A equal to C. So it never means A and C. It's not like crypto arithmetic. It does not mean that different letter represent different numbers. So it's fine if A is equal. Okay. But if you want some different example, let me give you some different example. Suppose A is 1 and this is say 3 and C is 2. 2 divides maybe 4. You want different numbers. But 1 plus 2 is 3 and 3 does not divide 3 plus 4, 7. Okay. Yeah. So for good.
Sir,
Yes, Kia.
sir, if you know that if A divides B, then A into Q1 is equal to B, no? Where Q is a natural number.
Yes, yes.
Then C divides D, then C into Q2 is equal to D.
Yes,
So,
yes.
so if Q1 and Q2 is equal, then the equation will, then the statement will hold that A plus C will divide B plus D.
Right, right.
That will happen if Q1 and Q2 are equal. But I am not sure if there are other cases that where Q1 is not equal to Q2.
Yeah, yeah. So what you're saying is correct. If luckily the quotients are same, that common quotient Q you can take together outside, and A plus C will divide B plus C. That is fine. But I mean more generally, why a result may not be true in general? Because yes, madam. Because uh, uh, the original conditions are about divisibility, so they are not about addition. So they are about multiplication and division. So possibly it may not be true for additions, right? If you go ahead.
Yes, sir.
Yes, sir.
Yeah. So I see many of you have given many nice counter examples for this question. Okay, one more in this true or false. Yeah, if D divides A and D divides B, and if A is equal to B plus C, then D divides at C also. And you all this divisibility, etc., we are working in integers only in general. Okay, Gautam is saying if A is equal to B, the result is true. Gautam, if A is B, then obviously C part has to be 0, and then obviously everything divides 0. So result will be obviously true, right? What if A is not equal to B?
Sir, I gave another proof for that.
Sir, I said it. I gave the solution, sir.
Okay, but don't disclose it.
No, I am not disclosing. No.
Yes, Gautam. Yeah. Okay, so again, most of you are saying true. There are one or two false, but they haven't produced any counter example. So let me go with this answer because those who have said false, they haven't produced any counter example. Yeah. So the answer is basically true for this. Okay, if D divides A and D divides B. Now D divides A, what it means? So implies A is D times some integer. So let's say M or some integer. Right? And because we are taking in this case all are natural numbers, so even I can assume that M is natural. But more generally it could be integer. D divides B implies B I can write as D times something for some integer M. And again, all are natural numbers positive, so even M n will be natural numbers. A is B plus C, which means I can write C as A minus B, right? And A is D times M minus B is D times N. So I can take D common. So D times M minus N. Fine. So anyways, M minus N, whether positive or negative, in any case, it's some integer. Natural number minus natural number is again always integer. Fine. So D times some integer is C. So I get C is equal to D into some integer, which means D divides C. So answer is true. Yes, Kian?
Sir, could you repeat that?
Sir, we can just start with if A is equal to B plus C, and so we can say that C is A minus B. Then so we will need to prove that D divides A minus B, and we already know that from if D is equal divides A and D divides B, then
So if we want to use those earlier properties, then we can say even directly. But let's say without any property, you can prove it.
and D divides A minus B. So we have proved that if A is equal to DM and B is equal to DM, so A minus B will be DM minus DN. So we can factor DN. So C is also divisible by D.
Yes.
It's
Yeah,
similar.
I'll repeat the argument. Somebody wanted it. So once again, D divides A. And what it means, D divides A means A is equal to D times some integer. So I'm saying A equal to D times some M. Fine. Similarly, D divides B, which means I can write B as D times something. So D times maybe some different M. Okay. And we want to claim that D divides C. That's our final job. So which means I have to prove that C is D times some integer. Okay, that's our goal. So firstly, what is C? C is A minus B because A is B plus C. So C is A minus B. right? And I replace now A in terms of dm, B in terms of dn. So A minus B is dm minus dn. So I can take d common. So it's d times m minus n. And don't worry with letters. Essentially, they represent some integers, some numbers. So I get C equal to D into something, D times some integer, right? Note M minus N may not be natural. If M is smaller and N is larger, then M minus N could be negative. But anyway, it's an integer. So D into some integer is C. Is that okay? So D divides C. And yes, Dhruvi?
So the reason I've put in the chat box, is that true? Like, can we also use that?
Will you say it? What you use?
Sir, I've used that if D divides A, then A can be written as D times Q1 plus D times Q2, and Q1 and Q2 can be written as the integer B and C.
Yes. Yeah. Okay. Shall we go ahead?
Yes,
Yes,
sir.
Yes, sir.
So we'll stop with this true and false. We'll take some different type of problems. So I'm numbering again 1. So these are different kinds of problems. Find all possible rectangles with integer sides, and obviously lengths are always positive. So basically, though I am saying integer, they are positive integers. With integer sides whose perimeter equals twice its area. Yes, so read neatly once, twice, try to understand the meaning of the problem.
So do squares count as rectangles?
Yes, yes. A square is always a rectangle where length breadths are equal. Converse may not be true. So every rectangle may not be square, but square is always rectangle. Yes, so let me draw one rectangle. So suppose the sides are A and B, where A, B are some positive integers. So I'm saying here A, B are natural numbers. Fine. So how much is perimeter? Perimeter is
Twice the area.
So, I mean, if length and breadth are A and B, what is the perimeter of rectangle? Perimeter is sum of all the boundary sides. So it's A plus B. This opposite side is again A. This side is again B. So it's basically 2 times A plus 2 times B, right? So 2 times A plus B. And what is area? Area is length into breadth. So that is A into B. So basically, given condition says that perimeter is, so given that perimeter is twice the area. So 2 times A plus B is 2 times AB. Yes, Raksha?
Sir, in the question you said the rectangle sides are integer, but while writing you wrote it belongs to natural number.
Yeah, so because sides are never negative, right? Lengths are never negative. So they are positive, and positive integers are nothing but natural numbers.
Okay, sir. Thank you, sir.
Okay, so basically what I 2 cancels, and what I get is A plus B is AB. So we have to solve this equation with where AB are integers.
Sir, may I continue?
Wait. So let others also think.
Sir,
Yes.
I think the only possible
Don't disclose the answer. Kia. Don't disclose
Huh?
it. Don't disclose the answer.
okay.
Let everyone get a chance to think. In fact, such problems were studied by Babylonians, and in fact, that gave rise to the concept of quadratic equation or degree 2 polynomials. Yes, shall we start discussion of the solution? Is the question clear, or have we formulated in nice?
So I have a doubt.
Yes, Siddha. Yeah, who had doubt?
Sir, can we take 0 as A and B?
Basically, no, because they are sides, and generally, I mean, in standard case, we assume that sides are positive. See, 0 side is just a point. Then it won't give us rectangle.
Sir, I formulated my solution.
Okay, yeah.
My solution is this. We are given A plus B equals AB, right?
Yes.
Take all the terms on the left-hand side to the right-hand side. 0 equals AB minus A minus B.
Siddha, just a minute. I'll go to next page. So Siddha solution, just a minute. Siddha solution. Siddha, how do you spell it?
SIDDHARTH. My solution is this. We start from A plus B equals AB.
Yes, A plus B is AB.
Take all the terms on the left-hand side to the right-hand side. 0 equals AB minus A plus B. Sorry, AB minus A minus B.
Shall I say AB minus A minus B is 0, right?
No, this is almost factorable, but to make it completely factorable, add 1 to both sides.
Okay.
The left-hand side factors as A minus 1 into B minus 1. Now, A and B both need to be integers, that is positive integers. And the only factors that are positive integers are 1 and 1. So both A minus 1 and B minus 1 need to be 1, giving us A equals 2 and B equals 2 as a solution.
Okay, so product of two integers is 1. I mean, in fact, two natural numbers is 1.
Yeah.
So basically, A minus 1 must be 1 as well as B minus 1 must be 1, right? So A is 2, B is 2.
The other solution would be -1, but then you'd get 1 point. A equals 0, B equals 0, which doesn't exist.
Yeah, yeah.
So that's the only solution.
Okay, but Siddharth, how one will get idea to add 1 and factor it?
The idea is this. You start from basically you get AB minus A minus B equals 0. So I could like draw a little arrow from that.
Mm-hmm.
Basically, like you'll get A into B minus 1 minus B equals 0.
Okay, yeah. So you take
Yeah,
A
and
common
then
from two terms.
you want another B minus 1, so you have to add 1 and get minus B plus 1, and then yeah, like that.
Okay, fine. Yeah.
That's the solution.
Yeah. Shreya, do you have some other solution?
Yes. So just
If it is different
yeah.
from this, you can say. Yeah. Just a minute.
So B is equal to AB minus A.
Yes.
Now this can be factorized as this can be factorized as A into B minus 1.
Yes.
So B minus 1 divides B, since we know that A is an integer.
Oh, very good. Yeah. So B minus 1 divides B. Yes.
And B minus 1 divides B, every number divides itself.
Yes. Also,
So
B minus 1 divides itself.
and we already know that if x divides y and x divides z, x divides y minus z. So B minus 1 divides B minus B minus 1, which is equal to 1.
B minus 1 divides the difference of these two, and that is 1. Right? So implies
Yes.
B minus 1 must be 1. So implies B is 2. And just by symmetry, it's very much symmetric. Even if I change A to B and B to A in the equation remains same. So whatever I'm arguing with B, same I can argue with A. So on same lines, I can prove A is 2. Right?
Yes, sir. The solution I sent is wrong. I forgot to check the case where A is equal to 1.
Yeah. Yeah, this is good. This is very fine. But shall I say from this statement that I mean little different from your argument? Like you are saying B minus 1 divides B. So similarly, shall I say A also divides B?
Yes,
Right?
you can see
And
that.
and similarly, so you interchange roles of A and B. So similarly, you can prove B divides A. Okay, just the way you have said A divides B on same lines, you can say B divides A, right? And then together, if A divides B, B divides A, together what I get is basically A is equal to B.
Yes.
And once
Yeah,
A
that
is
will
equal to
also
B, you
work.
can put it A in that equation. So A plus A to A is equal to A square. And we are working with natural numbers, so I can safely cancel A. A can't be 0. So 2 is equal to A, cancelling 1 A. So A is 2 as well as B is 2 because A is equal to B.
Yes, so this is a much shorter method.
No, I mean your answer is fine. Only thing, just a variation of what you said. So instead of B minus 1, I focus on A.
Yes, sure.
Is that okay? Yeah. Anybody has any other argument? Dhruvi, do you have some other argument?
No, sir, I didn't actually understand the solution.
Okay, which one? Siddharth or Shreya?
So the one given by Shreya.
Okay, yeah. Just a minute. I'll say it once again on next page. Yeah, so we have AB equal to A plus B, right? And take one term on left side. So AB minus A is B. Okay. So A common. Into B minus 1 is equal to B. So anyway, this is integer, in fact positive integer. So B minus 1 times some integer is B. Times some integer is B. So which implies B minus 1 divides B.
Okay, sir.
Now also what one knows is, see generally all these are in terms of some variables A, B, etc. So somehow idea is try to get rid of those variables and try to get some constants. Once I get something divides 1, something divides 2, I get some concrete answer, right? So idea is try to eliminate B. That was the idea. So also B minus 1 divides itself, B minus 1. Do you agree with this?
Yes, sir.
Yeah. So which means B minus 1 divides addition subtraction of these numbers. So B minus 1 divides B minus 1.
Yes, sir.
Which means B minus 1, shall I write on right side? So which means B minus 1 divides 1. On this side, what I get is 1. B cancels, what I get is minus of minus 1, that is 1. And only number which divides 1 is 1 itself. So we are working with positive numbers. So B minus 1 has to be 1.
Yes, sir. Got it.
Sir,
So B
may I,
minus 1.
may I suggest something?
Yes, that.
Like from when we get B minus 1 divides B and B minus 1 divides B minus 1, you can already get its 1 because B minus 1 and B are always co-prime, except for when 1 and 2. That's the only case.
Yes, but so far we haven't done those
But
things.
that's a better fundamental method. Yep.
Yes, but so far we haven't done those terms like co-prime, GCD, etc.
Okay.
And yes, Anju?
Sir, I had another solution.
Okay, good. Yeah. Just a minute, I'll go to new page and you can say that. Yeah, so who wanted this proof? Dhruvi, I think. Yeah, Dhruvi, do you understand this?
Yes, sir. Yes, sir. Got it.
Anju, just a minute. So let me finish this. So B is 2, and similarly by symmetry, you also get A is 2, or you put value of B as 2. So I get 2A is equal to A plus 2, and that will again give me, so 2A minus A is equal to 2. Is that fine? So B is 2 will imply A is 2. Yes, Anju.
So I did A plus B is equal to AB. So A plus B divided by AB is equal to 1.
Oh, good. Yeah, very good.
So 1 by A plus 1 by B is equal to 1. And we know that as any value, 1 by something, as that variable becomes larger, 1 by it becomes smaller. So the only solution is 1 by 2 plus 1 by 2.
Oh, very nice. Yeah. So what Anju is saying is, if so because AB are integers, we can focus on bounds. So if A is greater than 2, and similarly as well as b is greater than 2, then if I take a reciprocal 1 by a, that will be less than 1 by 2, and 1 by b will be less than 1 by 2. So which gives 1 by a plus 1 by b will be less than half plus half, that is 1. So if both are greater than 2, then obviously the reciprocals will add up to something less than 1. They can't give me 1. Everyone agrees? Also a can't be 1, because if a is 1, I get 1 plus 1 by b is 1, and that means 1 by b is 0, which again gives some contradiction, right? So if 1 by b is 0, I'll cross multiply and I'll get 1 equal to 0 into b, which is 0. So I get 1 equal to 0, which is absurd, or that is generally called as contradiction. Contradiction is something which is always false.
Sir, that is only possible if b is equal to infinity.
Yes, yeah. But infinity is not actually a number. It's just a symbol to say that there is no end.
Okay, sir.
Okay, so a can't be 1, a can't be greater than 2, so a must be what? So a must be 2. Only choice left is 2. And once a is 2, I put it there in this equation. So I get half plus 1 by b is equal to 1, and which implies 1 by b is 1 minus half, that is half. So b is 2. Are you good? Yeah. Asreya?
So how do we know that A there is not? Okay. Yeah. Sorry, sir.
Kushal?
So if A equals 2 and B also equals 2, you ask for like a rectangle, right, sir?
Yeah, so in that case, it's a square, and every square is obviously a rectangle.
So, but then the sides are equal.
Yeah, it's fine. So rectangle is, what is rectangle? So the 4 angles are 90 degrees. That's it. Sides may or may not be equal in case of rectangle, right? So every square is obviously a rectangle because all 4 angles are 90 degrees. So square is always rectangle. Rectangle may not be square. See, for example, now I'm staying in Maharashtra. So every Maharashtrian is Indian, but every Indian may not be Maharashtrian. Okay? So every square is rectangle, every rectangle may not be square. Rectangle is a much general term than square. Fine? Yeah, Nimal, do you have a doubt?
Sir, so I can't understand how A plus B divided by AB is equal to 1 by A plus 1 by B.
Okay. So just a minute, I'll go to new page. A plus B upon AB, that is equal to A upon AB plus B upon AB, right?
Yeah, sir.
So this is now, so A cancels here. So I get 1 by B plus here B cancels. I get 1 by B.
Okay, sir.
I can of course change the order and write it as 1 by A plus 1 by B. Yeah, so just based on this idea, this puzzle, so in this case what we did, something like A plus B, we want it to be equal to AB, right? So just based on this idea, let me give a little more challenging question or puzzle. Find 1000 integers, or I mean positive integers. Find 1000 positive integers whose sum equals their product. Yeah, so in this problem, what we got, sum of two numbers was equal to the product. Now I want similarly on same lines, 1000 positive integers whose sum equals their product. So can think about it. So that's homework. Srividya?
Sir, is it okay if they're not distinct, if they are like they're like some like
Yeah,
30 of the same
yes,
number
yes.
or something?
Yeah, so may not be distinct.
Sir, then I have the answer.
Okay, but tell me next time in the start, in the beginning. Okay. So right now I don't want to disclose the answer.
I have an idea.
See that don't disclose the answer.
Okay.
Okay, then we'll stop for today.